Hello to everyone. Welcome back from the coffee. So I introduce Ty Smith, Tech Lead Manager and Google Developer Expert at Uber. So please welcome Ty and have a nice talk.
Thank you. Hey everyone. Today we're going to walk through some strategies for building the best user interfaces for developers. We'll pay special attention to font choices and color schemes. Wait a minute, this maybe isn't the right audience for this one. Okay, that looks a little bit better. My name's Ty, and I've been working on mobile developer products for many years at big companies like Twitter and Uber. Sometimes those developer tools have been focused on external customers, like external APIs and open source projects, and many times it's just working with other teams at Uber. Either way, I'm going to walk you through some ways to think about building great libraries and tools for mobile developers, and try to help bridge the gap for those of you coming from a consumer world. Today, the content will be pretty high level, and will be broadly applicable to developer tools. But when I dig into many of the examples, we'll be using some of the Android open source projects that my team has put out at Uber. First things first, I want to establish common vocabulary. So today we're going to be talking about building great user experiences, but in our case, our user is our developer. And so we want to take those common ideas of what is a good user experience and apply that to our developer customers. So for our topic, let me introduce you to developer experience, or DX for short. It's a less known but very critical way of describing this space. And it's commonly used within external engineering roles and developer relations folks as well. And this umbrella term describes the research and recommendations that I'll present here today to help all of us build more intuitive software interfaces. I'll be covering a few large categories that should give you some insight into how to think about building a great developer experience. First, we'll discuss how to think about the product concerns for developers. Then we'll talk about what usability means within libraries, SDKs, and other tools. We'll move on to more important quality standards that will impact your customers' customers. We'll cover some tips for guiding you through the release process. And then finally, I'll give you some ways to think about engaging with and supporting your developer communities. So let's begin with the first areas to think about when building a developer product. The product ideation, customers, research, and process. Many of us have built apps for consumers before, but building for developers requires a different approach. A good product abstracts the complexities to the expected level of adoption for your customer base. But when you're creating professional products like developer tools, those abstractions may look quite different than a consumer product, and you may need to explicitly account for that different type of user. You'll still have to strive for things like consistency, simplicity, and an intuitive user interface. But the expected mental overhead to your customer is different than on a consumer product, where maybe you're having to account for a demographic with less technical expertise. Instead, your customers will be primarily focused on execution and results, and you should try to align your product goals to ensure their success. In short, your priorities should be similar to consumer products, but executed differently, focusing mostly on efficiency and accounting for a much higher mental threshold for your customer base. In a more traditional consumer product workflow, you may have a product lead that envisions an idea. And then that product lead works to do, they may do individual market research to understand the scope of the problem, and then they'll lean on UX research, designer prototypes, and the engineering leads to flesh out the early scoping of the product. Once there's confidence and detail, the engineering team would build it out. In this standard world, there's an expected level of abstraction between the developer and the end user. The product design and engineering jobs leads is literally to bridge the customer expectations and requirements into the technical requirements needed for implementation, while the developers may not have or really need as much engagement with the customers directly. So in short, while it's not ideal, it's not a hard requirement that developers have a direct customer empathy as long as the product team does. But it's a quite different dynamic when the customer is the developer. Where a normal abstraction would be expected between the customer requirements for a product and the developers, now the developers relate directly to the customers building out the process. So why would we need product roles at all in this world where we have developers building for other developers? Well, in my mind, there's two major driving factors that speak strongly to the need for product abstractions in developer tools. The first is the need to focus on specific areas of impact. A developer who is context switching constantly between product strategy, market research, building the actual tools, and customer engagement is going to get pulled really thin and will most likely be frustrated and be less productive. While your developers will probably take a much stronger hand in engaging with the customers and just in general working with the product side, because they'll feel more expertise because they're working with other developers, it's still important to give them the ability and time to focus on building the best possible tools and to segment responsibilities appropriately amongst the different roles in the team. There's a cognitive bias called the expertise bias. The more expertise someone has in a specific topic, the harder it is to empathize with someone who's new to that topic. Tim Van Dam once gave an excellent demonstration of this problem using the slope of a mountain. From the base of the mountain, the top seems unreachable. From the top of the mountain, it doesn't seem like the climb was so hard after all. You at the top of the mountain tend to forget the fear, the confusion, the shame, the sweat, the impasses, and the temptation to give up until the summit was within reach. And this can be a large constraint in product design for developer tools. This one is much less apparent than the first issue, but it can be significantly worse in my mind. As people grow closer to the product and the specific goals being solved and working with those APIs, it's a lot harder for them to put themselves into the shoes of someone who's completely new to that. While this isn't exclusively true to developer tools, thus why UX research with new users is a pretty common process at lots of companies, I think it's easy to be a more prominent problem than when developers are building for other developers. They'll more often take the product interest and be involved in the process at an earlier stage. There's a very hard to find balance between empowering your power users and building the railing to onboard new users, especially as they may have varying levels of domain expertise. When building tools, engineers have a strong tendency to project their own experience onto their imagined customers. So that quickly adds pitfalls where things may seem trivial to the author, but it would be overly complex to a new engineer that's touching the API for the first time. So what is a product's role in developer tooling? Well, many developer product teams really don't have product managers, or they have a reduced number of them to the number of engineers that they have. However, I think that's pretty generally a mistake. And that to build really successful developer tools that get large public traction, you do need to rely on the product roles within your organization. Albeit, I would expect that the product folks and the design folks that you're working with on a developer tool would be a lot more technically minded than maybe their consumer-focused counterparts, and that'll also help them build up the customer empathy that's required for their role. Remember that developers are humans too, and they want usability, they want good designs, they want emotional attachments to the tooling they're using. So let's dig into some ways to think about product design for developer tools. My preferred framework for thinking about solving problems for your customers, and especially for developer customers, is called the Jobs to be Done framework. This framework was designed by Clayton Christensen and Scott Anthony and published in the Harvard Business Review to address thinking about the overall job and secondary jobs that customers are trying to accomplish rather than a specific business goal or something bounded to one business metric. This covers both the logical and the emotional aspects to the customer's choices. So a job in this example that I'm going to talk through is just a shorthand for a customer's real goal when using a product. So if you dig into this process, one of the first examples given in the white paper is an interesting study on this fast food restaurant. They wanted to sell more milkshakes. And so when they started researching their customer base, they realized, surprisingly, that the largest percentage of folks that were buying milkshakes were buying them in the morning. On further digging, they found the customers were buying them in the morning to keep them entertained during a boring commute. These were folks that were driving, they were stuck in traffic. The milkshake was a way that the customer was staying more engaged, they were entertaining themselves on this commute. So in this example, the competitors to the business trying to sell more milkshakes wasn't other fast food restaurants also selling milkshakes. It was other things that someone might pursue as entertainment and consumption for breakfast. So it was things like smoothies and fruit and yogurt and other things that someone might have. And this allowed the company to make adjustments to better fit that demographic. They increased the consistency of the milkshake so that it was slower to drink, so that it would keep folks entertained for longer. They reduced the straw size for the same reason. They targeted more breakfast flavors, like a coffee milkshake, things like that. And so by targeting the real job of the customer, they were able to make a huge improvement in the number of sales that they were driving. So let's look at crash reporting as an example of a developer product with the jobs to be done framework. What does the customer want when they set up Firebase crash reporting or Bugsnag or something? Do they want to just measure their crashes? No. They want their product to be successful. To do that, they need stable software to give their customers trust in the product and to give their engineers time to work on building real business features rather than fixing crashes. They need insight into the data around stability to improve it. But this also immediately shows other areas for product innovation for a team building out crash reporting. For example, if they're seeking more stable software as the end goal of their customer, in what other ways could a developer tool provider think about granting that? Automatic crash recovery, user feedback tooling, static analysis on buggy code. There's plenty of directions that could be pursued. So we've been talking about the developer customer quite broadly, but that's also an important thing to quantify when strategizing for developer products. There's quite a difference in the way a student may work with your tooling and a senior engineer at Google. And there's quite a difference that each one of those people will bring in value as customers for your product. Each will have their own priorities and understanding of the broader framework they're working with. These differences in the customers need to be identified, measured, and then used within your product framework for planning the work that's going to be done, the APIs that you're going to design, et cetera. So by breaking up your customers into logical groups, you can start to apply those to your product framework, and you're able to clearly identify how a specific feature will impact certain parts of your demographic, and then how much time and effort your team should put into that. So at Uber, we identified 3 major groupings of developers for our external API: the head, the torso, and the tail. The head would include large partners that bring huge value to the company. These are experienced engineers, and they often have very high complexity in their integrations. These are partners like Google and Facebook and Amazon, and the huge people that you would expect. These were usually managed relationships. We had business development people on our side interacting with BD folks on their side. We had a partner engineer assigned to them. So we had this direct line of communication. And this was the smallest percentage of our customer base, but by far they brought the most value to us. The torso would then include your standard mid-sized startup. These were more often self-serve through the standard support channels, Stack Overflow, developer portal, documentation, GitHub, et cetera. And these would bring experienced engineers, and they'd bring moderate value with lower support requirements. These companies could eventually turn into head partners, although that's pretty rare in general. And then finally, we have the tail developers, and this is the largest set of the developer base, but it's also the lowest value. This includes things like students that are just playing with your SDK for the first time and spinning up a hello world, or indie developers that are building an app that potentially has very low distribution, and very, very small companies. These are entirely self-serve and use the standard support channels, developer portal, and documentation. As we're thinking about building new products, understanding the effort to value spend is a pretty important requirement. In addition to grouping by demographic, we also create common personas to describe the way people work and what they care about. For example, a startup founder that wants to quickly bootstrap, a student developer that wants their handheld as they learn, an enterprise developer that may have significant rigor, a product manager who just wants a specific feature that a tool provides. All of these folks would value different things, and those vary from the ease of integration to the flexibility to the feature polish. Creating real personas around our customers ensure that we adhere this framework for matching jobs to customers. The Mozilla Foundation has a great set of public developer personas. I'd recommend taking a look there for a more thorough example. Besides identifying the customer group, it's incredibly important to get hands-on understanding from your target demographics. Just like with consumer products, doing the hands-on research with your customers to identify issues and product concerns are crucial to building great products. When I was at Twitter, we regularly ran UX research sessions on external developers. We watched them integrate the product, asked them well-defined and prodding questions about their expectations and feature requests, and then that insight was funneled back to the engineers and the product team to empower new features going into new sprints, et cetera. And all these sessions were recorded and streamed with anyone on the team that wanted to watch it. And they were extremely insightful for most of your common engineers that didn't have a lot of customer empathy to have these expectations on how their APIs would be used, and then watch a customer sit and struggle with them for 30 minutes. So at Uber, my team has several internal customers, and we have a lot of open source customers as well. And we do regularly sit down with our internal teams and do similar user research to understand their requirements, their product reviews, and understand their general pain points. Finally, collecting larger sets of data asynchronously helps prioritization as well. This can go really far in helping you understand more of the pain that you're not getting out of just user research. So we often use surveys, questions, and analytics to gather more information about how people are using our tools. Getting the right data from your customers ensures that you're solving the right problem. One potentially hard area to call out for thinking about the product concerns our developer tools is how to measure the success of the product. The 3 high-level goals you should strive for to move the needle on are developer productivity, developer happiness, and developer trust. Clearly, these are pretty nebulous, and tracking them can be difficult. Productivity creates business value, happiness creates ambassadors for your product, and trust creates loyalty. Measuring them through NPS, research engagement, developer analytics, and the other possible signals that you could get, for example, if you were on GitHub, you have the engagement numbers there, will all give you partial signal to these areas. So applying a number of these is going to be your best bet. Now, you should be able to envision a developer tool that solves a real job for the customer, using input from the engineering experts on your team, understand which segment of your group it would target, and therefore how much value it'll bring. Understand who needs the complexities and who needs speed of integration, how to measure your audience for feedback, and finally, some North Star goals to apply. So let's move on to making some usable software. Usability is thrown around in consumer products quite a bit. The app should make sense to the user, text should be self-explanatory, designs accessible, and user flows should be simple, concise, and intuitive. It should be the shortest path for the user to accomplish what they need. But what does that mean for developer tools to be usable? Well, it's very similar, conceptually, to the goals that I just mentioned, but the surface area is quite different. The surface area should be the concepts that in your tool that the developer interacts with directly. Developers are just people, and they prefer usable and well-designed tools too. And this increases their happiness in the workspace. However, as we talk about different customer personas, it's important to understand how to make it usable for each one of the groups. Usability in your tool and APIs can make or break the developer experience. It's a serious endeavor while improving our surface areas. So let's get into some of the priorities to think about when we're trying to make APIs that are easy to use and hard to misuse. For these examples, we'll be working with one of the libraries built at Uber, AutoDispose. It's a tool for managing RxJava subscriptions automatically to prevent leaking them or having lifecycle conflicts. I won't be giving a full overview of the tool, but instead I'll be picking and choosing APIs that I find to demonstrate the different qualities that I want to talk about. So it's important to consider how fast a developer can onboard your tool into their application. You should strive to allow integration with minimal boilerplate and configuration in minutes, and be able to show value to your customer right away. This can vary a lot, from a small library that can be used on demand with a single method call like an image loading library, to an analytics library that requires initialization with the app lifecycle, event recording, and recording back to a backend server. Here's an example taken from our auto-dispose library, which manages RxJava subscriptions, so you don't have to worry about tracking unsubscribes. Add the dependency to your Gradle project, and then you have just one method call that you're able to use to manage the unsubscription. And this just chains into your Rx chain like any of the other transformers. It couldn't be much easier. The APIs provided should also be simple and concise. The more boilerplate, ceremony, or reading that's required to use an API, the more likely it is to be dropped or used incorrectly. Google recently sanctioned Kotlin as an official language for Android, and while the community momentum existed prior, one of the biggest reasons for its successes has been bringing more conciseness to Android. The primary API for auto-dispose is both simple and concise. And the API directly expresses that as it's converting the chain into an auto-disposable chain. The API should be self-explanatory and intuitive. A developer should be able to understand what is going to happen without any surprises by looking at the name of the classes and methods. They shouldn't require a certain ceremony to use successfully. The way it works should be clearly understood from the developer without having to dig in or to retrain any behavior that they may already have. So here I show the vanilla RxJava subscriptions, where you need to manage your subscription and unsubscribe in a destroy event to prevent it leaking. Versus the auto-dispose way, where the ceremony is taken away from the user, and it becomes much more intuitive. Your tools should both be consistent with the platform best practices, as well as within the APIs of the tool. On Android, for example, distribute open source code, deploy a binary to Maven Central or JSON, use the Android frameworks and patterns. Just like a design language exists and is used for each platform so the user doesn't have to learn new paradigms between each app, libraries and tools in a domain should have similar adherence. The API should also be consistent with each other. Use similar wording and tense so that you don't have to teach different concepts to your customer. For example, in auto-dispose, we need to be consistent within its own APIs, within the RxJava patterns for observables, and with Java's patterns, Android's patterns, and with Kotlin's patterns. So here in a simplified view of our scope handler interface for converting different types of observables, we can see consistency in the naming style of the APIs, alignment with the RxJava types, as well as integration with error-prone via the check return value to enforce behavior on the Java and on the Android side. You should be thinking about composition in your public interfaces to avoid leaking implementation detail and guaranteeing the end product for your developer customer. For composition and auto-dispose, we ensure that all public calls expose interfaces to the developer and avoid having direct classes that are exposed. And this helps us as the maintainers to ensure backwards compatibility with the API when we update it. It helps developers in testing, and it ensures otherwise edge cases related to interacting with non-public classes or underlying RxJava classes are avoided. In the example above, I'm showing a subscriber proxy. This is for an observable, and you may have seen these returned from the previous slide's scoping logic. This proxy wraps the RxJava observable subscriber method so that the end user doesn't interact with them directly. Composition helps to increase the resiliency of your APIs, but there are other ways to do that as well. And in general, your APIs should be resilient, defensive, and safe to use. For example, if a method takes an object parameter, it should either be immutable, a primitive, or it should make a copy to prevent the user from mutating or causing race conditions. Data classes and configuration-rich objects should use builders to ensure they are in a valid state for use. The APIs themselves should appropriately hold on to weak references of lifecycle-based Android components to keep from leaking, and be intelligent about not returning the results in exit scenarios. And it should not be easy for a developer to do something incorrect with a well-designed API. In this primary method of auto-dispose, we're proxying the subscribe method so the developers never deal with any of the underlying classes. In addition to having resilient APIs and libraries, you should consider whether proper flexibility and extension would benefit your customer and allow different customer personas to utilize the product to their liking. This adheres to the open-close principle. Open for extension, but closed for mutation. It's unlikely you'll cover every use case that's needed. So by having an opinionated extension point or set of points, you can allow, and then have a mindset for how composition would work. You create these different building blocks, and you allow developers to compose them and extend on them as they need it, which gives them additional flexibility in using your tooling, so they may not need to look at a competitor if there's something they need that you don't provide. For example, in AutoDispose, we have a number of extension points, including your own lifecycle events. So you can provide your own implementation for use for different signal unsubscriptions based on your app's own creation and termination points. There are many approaches to extensibility that could be pretty useful, from creating separate adapter packages, to integrating your library against common third-party libraries, to providing open classes for extension, to allowing custom execution within your library's context. Another interesting example from what we do in AutoDispose is we use separate packages for interacting with many of the popular Android frameworks and libraries, and gives AutoDispose first-class support for many of those there, including Android itself, architecture components, Kotlin, RX Lifecycle, and many more. And the APIs should be testable by the end user. Developers shouldn't be testing the business logic of your library, but they should be testing the integration points to be sure that the behavior, the inputs and the outputs from that are as expected. If the library is unable to be used in a testing environment without making real network connections, then that's an issue. Think about stubbing, mockability, fakes, and the ability to run in a pure JVM environment. Ensure the customer is referencing an interface as opposed to the implementation classes where possible. One approach is to distribute separate testing libraries that include tools needed for unit test frameworks to interact with the tool. So with AutoDispose as our use case here, there are a couple useful priorities for the developers to test with, properties for them to test with. One, as we described, is a surface area that allows to interact with AutoDispose as interfaces, which can allow proper mocking and stubbing. Two, and more importantly, we provide a test artifact to be consumed that's it provides additional functionality to be used. So this provides a test lifecycle owner, and it enables to emit fake lifecycle events. And this would allow testing of lifecycles in RxJava, which could be especially useful to customers who rely on custom lifecycle events. For example, we can easily verify that after the onDestroy has been called, no more events are emitted from a stream that you're interacting with. And when things go wrong, the developer should be able to quickly see the issue at its source. Be able to troubleshoot and diagnose the issue there. So give appropriate logging from your tool. More importantly, fail at the source when something bad is happening. More importantly, it may be tempting to try to catch an error and continue to fail gracefully, but a developer diagnosing a weird state for the user is much more difficult than a direct crash with a stack trace that's reported. So if your tool is completely optional and is crashing, you may choose to gracefully degrade in production, but that complexity is rarely worth it. So distribute your binary without obfuscation so that the developer can see the clear issue that's going on and then take steps to address that if needed. In AutoDispose, we have a plugin system modeled after RxJava's to customize the behavior for the library. For example, you could set your own handler for lifecycle issues. For more controlled environments, we allow it to be locked down so that the configuration is done initially, followed by guaranteed usage by the clients. In this case, if the client code tries to mutate the configuration of AutoDispose later, it'll throw an exception and crash the application. This behavior is more easily diagnosed than if it was to throw a no-op and then the developer's wondering why something isn't working. You should have clear, concise documentation, both in the code for IDE autocompletion, as well as broad examples and explanations, taking a situational stance on your README, and additional document pages as well. Java docs should be hosted and distributed alongside the binary in Maven Central. This will be one of the first entry points for your developers, so be sure that it guides them effectively. Sample code should also be available and distributed alongside the binary. It should be concise and limit complexity so the users can clearly see how to integrate and use the developer tool without getting burdened with understanding new concepts that's introduced that are unrelated to your core business. In this snippet taken from the AutoDispose sample in the repo, our onCreate method is doing very little besides the bare necessities to demonstrate the usage of the tool. The developer doesn't need to spend time reading the code around the usage to understand how to use the library. It should be clearly commented so the developer can understand what's going on. And the code itself should be production quality. since users will copy and paste sample code, and it will end up in the wild. All right, that was quite a few code examples to demonstrate API usability. If you follow these, your customers will be off to a great start. But that's not all that's required. Let's move on to talk about quality-oriented properties that you should also care about. Besides usability within the software, where we focused on the direct effects of your tool on the developer, there are a lot of indirect quality issues that can cause issues for your customers as well, and sometimes even affect the customers of your third-party developers. So let's follow a principle of healthcare professionals and do no harm to the customer's app. And this needs to be prioritized if you want to make a successful product. The last thing you would want is to create a worse experience for the developer or the customers of the developers. The quality focuses here require aligning with the developer on the important considerations for their app and what will help them be successful and support their processes. The benefit of aligning on these considerations is building trust with your customer base. So let's dive into a few examples of how to improve what side effects you put on the customer. Stability should be at the top of mind when working on any sort of developer tool, a library, an SDK, a plugin. Not only will it crash for an end user, erode trust with the developer, it's also much more timely to fix than a bug in an app. Here, let's consider the timeline for fixing an average issue in a library that's being consumed by a third-party application. Even if we, as the providers of the library, discover the issue early and we ship a fix, it could be months before the developer picks up that fix, and longer still before they get that distributed to their customer base and they do an update. So it's possible for library bugs to literally live in the wild for months longer than standard app bugs. Similar to importance of keeping a stable product for the customer, libraries also need to do no harm when it comes to performance. Do everything possible to be as performant as possible. This means using appropriate threading, memory management, and try to take advantage of the existing resources when possible, like thread schedulers and file caches. Run profiling tools during development and test on older devices. And this is an area that can cause real frustration for end users. You'll more often hear app size discussed as a constraint in reference to Android. However, I believe it's relevant to both platforms. So if you happen to be cross-platform, consider this for iOS as well. Devices have limited space, and cheaper devices have even less. In addition to binary size, you have constraints around traffic size, cache sizes, memory size. On older versions of Android, even method count can be a problem. When multi-decks can cause slowness in the startup process for some older devices. All these are going to impact the users negatively, and that will be disproportionate to the lower-end devices and emerging market networks. At Uber, for example, we ship a light version of the Uber Rider app called Uber Lite. This targets India and some of the Middle East and some of South America, and in those areas, you have a average device that's a much worse performing device with a lot lower resources. So we specifically target staying single decks and under 5 megabytes on disk for the Uber Lite application. So what does this have to do with a developer tool? Well, if your library is embedded in an app at runtime, it needs to minimize where it impacts on size. When a developer decides to prioritize trimming and reducing to meet these expectations, looking at third-party applications and developer tools and seeing where they can trim the fat and pull off dependencies is probably one of the first things that they're going to do. And you don't want to be in a prominent conversation between, as the subject of engineers talking about how to reduce their size. You don't want your library to be on the chopping block. And unlimited data plans have gone in and out of fashion around the world in many countries, and a cellular chipset drains a significant amount of battery. Do you know that in many emerging markets that users pay by the kilobyte still? And they even read change logs to make the decision on a specific update for an application. So these are all reasons you should prioritize batching requests to avoid keeping the chipset active or in a waiting mode, and being conservative with what needs to be sent, and using protocols that take advantage of compression over the wire, like gzip or protobuf. Here's a fun example of a guy I found on Reddit who was talking about his $500 phone bill after Google Plus went wild and ate over 20 gigabytes of cellular data. Another area where it's really easy to accidentally bring some pretty bad side effects down on your end user is when libraries choose to use third-party dependencies and those get pulled into an app transitively. And subsequently, any libraries those have chosen got pulled in, and so on and so on. It's not always feasible to avoid third-party libraries entirely when you're building developer tools, but unlike app development, you should be extremely conservative with pulling in those dependencies. Not only will they add size to the application for the developer, but it's possible for you to introduce dependency conflicts. For example, in Gradle, if one library pulled in v1 of a transitive dependency and a different library or the main app pulled in v2, by default, Gradle is going to resolve that conflict by pulling in the highest version. And if there's an API difference, you're going to see a runtime crash or a behavior change. And those could potentially get shipped into the wild if that's not in a common testing flow for that end user. So if you keep these overall quality metrics in mind, it'll go a long way towards building developer trust. And after ensuring the usability and quality of your tooling, defining a consistent release process that developers can trust is important. As we discussed, use the best practices for your platform here. So on Android, deploy a release to GitHub or GitLab. Use Maven Central or JSONer for your binaries. Integrate against a public CI system like Travis CI or Circle CI to maintain code quality per diff. Let's dig into some specific concerns around the release process to ensure you keep developer trust high. To maintain developer trust, you need to be consistent and communicative with the updates to your tool. Semantic version is the idea here, that the major version is reserved for API incompatibility, the minor version is used for features, and the patch version is used for bug fixes. A developer should be able to use their work hours to focus on solving business problems and build features, not reacting to a third-party library, forcing a migration, and pausing other work streams. Be cautious when changing the API to avoid thrashing the developer. Secondly, developers won't always be able to update to the latest version. So over-communication is required to get them to understand the benefits or fixes that they should care about and get it onto their radar. Make it clear to the developer what has changed in the new version. Most do not automatically update to the latest master, but instead watch for relevant fixes or needed features. So make it explicit and link to the GitHub issues per version. Inevitably, you're going to need to do a refactor or remove code, and I'd recommend that you pay special attention to thinking about your process of deprecation. First, before any work begins, be thoughtful about adding new APIs to be sure that because you'll be supporting them for as long as possible. An API is like a baby. They're fun to make, but they take 18 years to support. So follow the guidelines we discussed for semantic versions so that the developer knows when there is an API change that they need to make when they're consuming an update of the library. Mark your methods or functionality as deprecated as early as possible while clearly defining the alternative. Never just remove code without giving your customers heads up. Make sure you communicate a clear timeline or version for your customers for when that functionality will be removed. Use multiple communication channels like GitHub, your blog, email list, developer docs, Twitter, however you're working with your developer communities, over-communicate this and be repetitive. Lastly, often you'll need to pair a feature with a desirable change along with the deprecation to get the users to actually be incentivized to do the update. This is kind of putting the carrot with the stick. So this photo here is a cake for my team when we finished deprecating the legacy DI graph in our iOS monorepo. It was a 6-month project to rip out the singleton-based DI system everywhere across all of our apps. It was chocolate raspberry, and it was delicious. With Kotlin, you can go one step further. By making use of the replace with parameter and deprecated, IntelliJ will then ask to quick fix this for the user and even give them the option to do it in the entire project, which helps simplify the migration. You can also do something pretty similar with error prone. If you're still using error prone in Java, you can use the quick fix tool in the error prone checker to automatically apply the fixes. This example here is taken from one of Autodispose's deprecated methods. Lastly, for a very successful project, it's very difficult to scale a team's resources up to account for the extra scope that's needed for a really large project. You won't be able to run a successful project by yourself. And one way to address this is by building an external community of contributors, helpers, and maintainers as early as possible. Engage on the standard platforms directly, like Stack Overflow, Slack channels, GitHub. Praise and reward helpful external contributions through thoughtful words or GIFs. Strive to drive your loyal customers and external developers to become ambassadors that help others onboard and learn about it as well. Not only will this help reduce the overhead of the core team, but it'll help create a healthier community and overall project. Jeremy Mice has, from XDA, formerly from XDA, I think he's somewhere different now, has a great talk on building open source communities that I'd recommend. It's linked here at the bottom of the slide. I want to emphasize having a clearly supported, a clearly defined support system. Set clear SLA expectations for your customers. Keep lines of communication as open as possible to constantly be getting the right kind of feedback from your developers to fix and improve your project. It's common for teams to put out products with the intention to maintain, and as time goes on and team priorities change and people leave, products rot in the wild. So at Uber, like most big companies, certain projects struggle with this, but it's something we're trying to address through more stringently defined owners internally, and this is an actual example of a conversation that happened in one of our projects, although I've anonymized it here. Keep an eye out for this type of thing in your project. Silence and issue rot signal to others that the project isn't well supported or maintained, and when they're debating different open source libraries to use, this would be a good signal to avoid yours. Set your expectation for public contributors. Call out the expected process in your README. Review PRs quickly, and be as collaborative as possible. Define your roadmap publicly if you can. If you're using GitHub, define the issues for the next version and propose ideas in the public for open conversation. This will help folks outside of your company feel engaged and will build a better product. And with that, we've had a pretty high-level overview of some of the considerations to take into account when building for developers. Some frameworks and tools to use when planning developer products, a dive into library and API usability, an overview of some specific quality considerations that you should have, some tips for having seamless releases, and some thoughts on how to engage with your community of developers. So I hope this talk provides some pointers for you to think about designing for developers. Please check out our open source projects. In addition to Autodispose, we maintain and many other great libraries as well, and we're always looking for more contributors. If this sort of work interests you, we're hiring. We have offices in the US and in Europe. And I'll be around to take questions after the talk. So please come and find me and feel free to talk about any of this. Thank you all for attending today.